So, here is the number 6 sample problem, and I will be discussing my solution. 4 pounds of air gain 0.491 BTU per gas constant of entropy during a non-flow isothermal process. If P1 is 120 pounds square inch absolute and V2 is 42.5 cubic feet, find the initial volume and initial temperature and the non-flow work done, heat transfer, and change in internal energy. So here is the given values. Mass, which is a constant, is equals to 4 pounds, and the change of entropy is equals to 0.491 BTU per gas constant, and P1 is 120 psia, V1 is 42.5 cubic feet, and this is a constant gas constant given gas constant for air, which is 53.34 pounds feet per pounds gas constant. And first, we can convert entropy change from BTU per gas constant to cubic feet per gas constant using the mechanical equivalent of heat, which is 778 pounds feet per BTU. So we multiply the 0.491 to 778 pounds feet per BTU. So we cancel this one, in able to get this unit. And we end up with 382 pounds feet per gas constant. So next, we also convert the 120 psia to pounds square feet, in able to match this one. And 120 psia has 1 psia has a 144 square inch per square feet. So we will be multiplying this one to 144 square inch, and we end up with the answer, which is 17,280 pounds per square feet. And next is, we can now get the final pressure. So using the entropy change equation for an ideal gas, which is mR ln P1 over P2, we can input this one, change in entropy, which is 382 that we got it here, and then the 4 pounds, which is the given mass, and the 53.34, which is the gas constant for air, and then ln the P1 the P1 converted P1 17,280, and then ln P2. So we end up with the final answer, which is 2,883.91 pounds square feet. And then next is, we can now get the initial volume using the ideal gas law, which is PV is equal to MRT, and then by transposing this one, we can get this formula, and then we can now input the following values: 2,883.9 lb times 42.5 over 17,280. So now we can get the initial volume, which is 7.093 cubic feet. And now we can get the temperature. I also using this P1 V1 equals MRT formula. Now, 120 times 7.093, which is the initial V1, and then is equals to for the given mass, and then the given gas constant for air, which is 53.34, and then the T. So, by inputting it, also you can use shift solve in the calculator. By inputting this one, we can end up with the final answer, which is the 574.46 gas constant. This is the temperature. And then next, now we can get the non-flow work done. By using this equation for an isothermal process, W is equals to P1 V1 ln V2 over V1. By inputting the following values, now we can get the final answer, which is the 282.06 BTU. And then next, now we can solve the heat transfer. So we all know that heat transfer equals to work done for an isothermal process. Since our problem is specifically said it here that it is a non-flow isothermal process. So now our heat transfer is equals to 282.6 BTU, just like it here, our work done. So, and then finally, lastly, the change in internal energy. The internal energy change is 0 for an isothermal process. So now, this is the final change in internal energy. Change in internal energy is equals to 0. So, thank you for listening.